question number 1. Find the area of the figure. Find the area of the figure bounded by the lines x is equals to 0, comma x is equals to pi by 2, y is equals to sin x, and y is equal to cos x. So this is the question. So to solve this question, first what we do is we will draw the graphs. Our limits are from x equal to 0 to x equal to pi by 2. So we will draw the graphs of y is equals to sin x and y is equal to cos x in between 0 to pi by 2. That is the first step. So to draw the graph of y is equals to sin x, so this x axis and this one is y axis. So the graph of sin x is, this is 0 to pi by 2. Suppose this is pi by 2. So cos sin graph sin 0 0, sin 91 at pi by 2, sin takes its maximum value. So this is the graph of what, the sin x, and we'll draw the graph of cos x. Cos 0 here this one is, so sin 90 is 1, this is 1. Here cos 0 is 1, cos 90 is 0. So this is the graph of cos x on the same coordinate plane. So now the question is, now area bounded by these two curves in between the limits x equal to 0, that is this one, this is x equal to 0, that is y axis, and this one is x equal to pi by 2. These are the limits. Upper limit is pi by 2 and lower limit is 0. So what is the area bounded by these two curves in between these two limits x equal to 0 and x equal to this area, this shaded area? So this area we need to find, this one and as well as this one. This is our required area, shaded region. So let this area be some A1 and this one is A2. This A1 and A2 we need to find. So now what we do is, if you, so what is the point of intersection in between 0 to pi by 2, where sin x and cos x intersect? At pi by 4, at x equal to pi by 4. Sin 45 is 1 by root 2 and cos 45 is also 1 by root 2. This is the point of intersection. Now what we do is, so our required area is, to find the required area, that is A1 plus A2. So in between 0 to pi by 2, in between 0 to pi by 4, the which graph is above this? Y is equals to cos x. Sorry, here this is actually, this one is sin x. Y is equals to sin x. This one is y is equals to sin x, and this one is y is equal to sin x. So this one is y is equal to cos x. This is y is equal to cos x. Yes. Now in between 0 to pi by 4, which one is above? Cos x graph is above sin x graph. That's why, therefore required area is, so required area is equals to, in between 0 to pi by 4, in between 0 to pi by 4, cos x is above, that's why cos x minus sin x dx, plus from pi by 4 to pi by 2, the sin x is above, the sin x is above, that's why from pi by 4 to pi by 2, sin x minus cos x dx. So we'll calculate. So this is equals to, so integration of cos x is sin x Integration of sin x is minus cos x, that is plus cos x here, minus minus. The limits are 0 to pi by 4. Plus second integral, integration of sin x is minus cos x, integration of cos x is just sin x. Limits are from 0, no sorry, pi by 4 to pi by 2. Pi by 4 to pi by 2. Now substitute upper limit, that is sin pi by 4 plus cos pi by 4 minus substitute lower limit, sin 0 plus cos 0. This is the first part, this A1 area, plus for this one, so minus cos pi by 2 minus sin pi by 2 minus of minus cos pi by 4 minus sin pi by 4. So which is equals to sin pi by 4, this is sin 45 1 by root 2 plus cos 45 is also 1 by root 2 minus sin 0 0 cos 0 1 plus cos 90, this is 0 minus sin 91 minus cos 45 is 1 by root 2 minus sin 45 is also 1 by root 2. So this is equals to, here 1 by root 2 plus 1 by root 2 is 2 by root 2, which is equals to root 2 minus 1 plus here minus 1, this is minus 1. So this part is minus this bracket, that is this is minus 2 by root 2, that is minus root 2, minus minus plus, that is this is plus root 2. So then what you get finally, this plus root 2 plus root 2, 2 root 2 minus 1 minus 1 minus 2. So this is equals to, final answer is 2 root 2 minus 2 square units. So this is the area, that is the sum of A1 plus A2. So this is the solution for first question. Next, question number 2. Find the area bounded by the hyperbola x square minus y square is equal to a square between the straight lines x equal to a and x equal to 2a. So this is your question number 2. So solution. So first what we do is, we will draw the diagram, that is this y axis and x axis. So we know this is this x square minus y square hyperbola. We know the graph already in coordinate geometry, we have seen how to draw this hyperbola. For this hyperbola, so these are the asymptotes, that is y is equal to x and y is equal to minus x. Sorry. So the hyperbola will be like this. Okay, this is the rough diagram. So now the question is, the area bounded by this hyperbola. So this x square minus y square equal to a square hyperbola, and between the lines x equal to a and x equal to a. So x equal to a will be So what is x equal to a here? So x square minus hyperbola is x square minus y square equal to a square. On x-axis y is equal to 0. If you substitute y is equal to 0, x square is equal to a square, therefore x equal to plus or minus a. So this is a comma 0 and this one is minus a comma 0. So here limits are given as x equal to a and x equal to 2a. So here lower limit is x equal to a and upper limit is x equal to 2a. X equal to 2a will be somewhere over here. So here the limits are the lines, vertical lines, x equal to a, this is lower limit, and x equal to 2a. So this is the upper limit. So now the area bounded by this x equal to, this is the, here limits are just vertical lines, x equal to a and x equal to 2a. These are the upper and lower limit. So the area bounded by x equal to a and x equal to 2a and this x square minus y square equal to a square is nothing but the shaded area. So the required area is the shaded area. So this area we need to find. So to find this total area, this graph, this curve is symmetrical about x-axis. So finding this total area is equivalent to finding this above area and 2 times of that above area. Suppose this above area, that is above x-axis from a to 2a. So this area is suppose a. So the total area is equal to 2 times of this a. That's why you calculate this area and 2 times of this area is this total required area. So for that one, what you do is, so required area is equals to, now therefore required area is equals to, from the curve x square minus y square equal to a square is the curve. From this one, y square is equals to x square minus a square. Y is equal to plus or minus under root of x square minus a square. Y is equal to plus or minus under root of a square. But I am taking the first quadrant, this part only. For this part only, I am considering this part. So for that one, that's why I am calculating the area in first quadrant. That's why you take with y with positive sign. So now the curve is, now you take y is equals to under root of x square minus a square. So now the required area is equals to 2 times of limits are from a to 2a, y dx. So what is y? With positive sign, because in first quadrant y is positive, therefore y 2 times integration of a to 2a. So y dx, y is what? Under root of x square minus a square dx. So now what about the integration of under root of x square minus a square? That is just standard formula only, that is 2 times of, so integration of, we have direct result of integration of under root of x square minus a square dx. So integration of under root of x square minus a square dx is equal to x by 2 into x square minus a square minus a square by 2 into log of x plus under root of x square minus a square. So this is the formula. So integration is x by 2 into, just you replace this formula over here otherwise. So this is the formula. Sorry. Yes. So now limits are from a to 2a. So this is equals to 2 times. Otherwise you take out 2 common and cancel out here. Therefore this is equal to x into under root of x square minus a square plus a square into log of x plus under root of x square minus a square, a to 2a. Substitute lower upper limit first, that is this 2a into under root of 4a square minus a square minus a square into log of 2a plus 4a square minus a square minus lower limit. If you substitute lower limit, so for x equal to a, this becomes 0. So this is 0 minus of a square into log of a plus this one is 0 again. So this is equals to this 4a square minus a square, that is 3a square, that is root 3a. Therefore 2 root 3a square finally. So this term is 2 root 3a square. Next term will be a square into log of this is 2a plus root 3a minus minus plus a square into log a square into log a equals to this is 2 root 3a square. If you take out minus common from these two terms, then what you get, minus a square you take out common, so that is equals to, just a minute, yes, if you take out minus a square common, in bracket you left with log 2a plus root 3a minus log a. So for this term, for this bracket term, log a minus log b, that is log a by b, use that result. So this is 2 root 3a square minus a square into log 2a plus root 3a over a. So here a take out common and cancel out, therefore 2 root 3a square minus a square into log of, if you cancel that a, 2 plus root 3. So this is the final answer. Therefore required area is this 2 root 3a square minus a square log 2 plus root 3 square units. So this is the final answer. This is the required area. This is the required area. So next question is, find the area common to the parabolas five x square minus y is equals to 0 and 2x square minus y plus 9 equal to 0. So this is the question. So yet the two given parabolas are, one parabola is y is equal to 5x square. So another parabola is y is equals to 2x square plus 9. So these are the parabolas. This is first one, this one is second one. Two parabolas are given. So now what we need to do is, here to solve this question, so we'll draw the diagram again. So these two are parabolas, therefore this parabola y is equal to 4x. If you draw the parabolas on the same coordinate plane, then what you get, so this is y axis and x axis. So the first one is y is equal to 5x square passes through the origin and coefficient of x square is positive, therefore it's a open upward parabola. So the parabola y is equal to 5x square will be like this. So it passes through the origin, vertex is at origin, it's open upward because coefficient of x square is positive. So here for second one also coefficient of x square is positive, so it is also open upward parabola, but it doesn't passes through origin. At x equal to 0, y is equal to 0 for first parabola. For second parabola at x equal to 0, y is equal to 9. Therefore, this parabola intersect the y-axis 0 comma 0, y-axis 0 comma 0. And this parabola meets the y-axis at 0 comma 9. So now what we do is, the second parabola is open upward, but these two parabolas, whether these two parabolas intersects or not. If intersect, where it intersects. So first we will find the intersection point, then after we will draw this parabola and so on. So now what we do is, we will try to find the intersection point. Solve 1 comma 2 for intersection points. For intersection points, otherwise right. For intersection points. So how to solve? Equate this 5x square and 2x square plus 9. So this is equals to what? 3x square is equals to 9. That implies x square is equal to 3. X equal to plus or minus 3. Plus or minus root 3, sorry. So therefore these two parabolas intersect at x equal to minus root 3 and x equal to root 3. So now we will draw the second parabola. It's open upward because the coefficient of x square is positive, and these two parabolas intersect at minus root 3 and root 3. So so the second parabola is like this. This is the rough diagram. So this is the second parabola. So where this parabola intersect the y-axis 0 comma 9, and this point is, that is x coordinate of the point of intersection. This is minus root 3. This one is plus root 3. So now the question is the area common to these two parabolas. So our required area is, so the area, so this is the required area. So the area bounded by, so these two parabolas. So this is our required area. We need to find this shaded area. So now what we do is, yes, now our required area is equal to, so here this first graph is this graph is y is equals to 2x square plus 9 graph, and this one is y is equals to 5x square graph. So now the required area is equals to, so the required area is equals to integration of minus root 3 to root 3. The limits are, lower limit is minus root 3, so this vertical line, and upper limit is this vertical line, that is x equal to plus root 3. And which curve is above here? Actually we don't, first what we write is minus root 3 to root 3 y1 minus y2. In our usual notations we will write minus root 3 to plus root 3 y1 minus y2 dx. So now we have to find which curve is above and which curve is below with respect to x-axis in order to decide y1 and y2. Actually we have drawn this diagram. So now what we do is y1 here. Now y1 is here 2x square plus 9. So y2 is this 5x square. So now this is equals to, now this is equals to minus root 3 to root 3. So here y1 is equals to 2x square plus 9 minus 5x square, so dx. So this is equals to integration of minus root 3 to root 3, that is nothing but 9 minus 3x square dx. So this is equals to, so, and yes, here this 9 minus 3x square is an even function. This is even function. So we know minus a to a f of x dx is equal to this property 2 times 0 to a f of x dx if f of x is even. F of x is even, so it's an even function 9 minus 3x square. There, that's why you can write this thing as 2 times 0 to root 3 9 minus 3x square dx. So now this is equals to, now if you integrate 2 times integration of 9 dx is 9x minus integration of 3x square is 3x cube by 3 cancel, this is x cube, limits are from 0 to root 3. So this is equals to 2 times, if you substitute upper limit, therefore 9 root 3 minus root 3 square, that is 3 root 3, this is minus 0, lower limit if you substitute, that is 0 only. Therefore finally what you get, 9 minus 3, 6 root 3 into 2, that is 12 root 3. So 12 root 3 square units is the answer. So this is the area. So that shaded area is, this area is this 12 root 3 square units. Find the area bounded by, find the area bounded by the parabolas y is equals to 2 minus x square and the straight line y plus x is equal to 0. So this is the question. Solution. So here one parabola and one straight line is given. So y is equals to 2 minus x square is a parabola. So this is first one, and y plus x equal to 0. That implies y is equal to minus x is a straight line. So oka parabola ichadu, next oka straight line ichadu. The area bounded by the parabola and straight line adugutunnadu. So ఈ ప్రాబ్లమ్ సాల్వ్ చేయడానికి what you do is, first okay, if you observe this parabola coefficient of x square observe cheste, here coefficient of x square is what, negative. That implies parabola is open downward. The parabola is open downward. So this is the simplest straight line. Y is equal to minus x, we know that is the line which passes through the origin by making an angle 135 degrees with the positive direction of x. So line and parabola. So next what you do is, we will find the intersection points. Ekkada intersect avutayo we need to calculate. Find the point of intersection. Solve 1 and 2 for point of intersection. For point of intersection. So for that one, equate 2 minus x square equal to minus x is end. Then what you get, x square minus x minus 2 is equals to 0. So if you factorize, then what you get, x square, this is minus 2x plus x minus 2 equal to 0. Therefore x into x minus 2 plus x minus 2 is equals to 0. That implies x plus 1 into x minus 2 equal to 0. Therefore x equal to minus 1 and x equal to 2. So these are the point of intersections. So this parabola and the line intersect at x equal to minus 1 and x equal to, what we do is, with before drawing the diagram, we know in usual notations the required area is equals to, manaki ela rastam, we will write in between minus 1 to 2, lower limit is minus 1, upper limit is 2, y1 minus y2 dx. We will write like this. But which one is y1 and which one is y2? Ikkada y1 enti, y2 enti? Y1 straight line and parabola, which one is y1, which one is y2? అంటే ఏది అబో ఏది బిలో ఉందో దాన్ని బట్టి చెప్తాం. అబో ఉన్నది y1, బిలో ఉన్నది y2. సో ఫర్ దట్ వన్ వాట్ యూ డూ ఈస్ minus in between -1 comma 2, let some number, simplest int x equal to 0, you check. So in between -1 comma 2 you take the number which x equal to 0, you put in, and parabola and line. If you substitute parabola, substitute chesthe emotadi x equal to 0 2 vastadi, you will get 2. And if you substitute x equal to 0 in line, you will get y equal to 0. You will get here 2 is greater than 0. So which one is above now? So parabola is above the line. In between what? In between this -1 and 2, which one is above? If you substitute x equal to 0 in parabola, we got 2. If you substitute x equal to 0 in line, we got y equal to 0. Because y is equal to -x కాబట్టి ఇక్కడ 0 పెడితే 2 వస్తుంది, ఇక్కడ 0 పెడితే 0 వస్తుంది. కాబట్టి which one is above? The parabola is above. That implies, అంటే parabola above అంటే ఫస్ట్ above రాస్తాం కదా, therefore y1 is parabola now. Therefore required area is in between -1 to 2. So which one is above? Now we will draw the diagram. Then after we will solve the problem. So if you draw the diagram, so in between, so this y is equal to -x is, this is the line, and y is equals to, the parabola is y, open downward parabola, because coefficient of x square is negative, and where it intersect the y-axis, we'll say on y-axis x is 0, it intersect at 0 comma 2 y-axis. So here it intersect the y-axis at 0 comma 2 and the open downward parabola. That's why if you draw the diagram, rough diagram will be like this. This is the parabola. So now and what are the point of intersection just before? Now we found the point of intersections are -1 and 2. Kabatti this one is, this x coordinate is, this is -1 and this is -2. So these are the limits. So this vertical line, this is lower limit, that is x equal to -1. So this vertical line x equal to -2 is upper limit. So what we have done here we substituted x equal to 0 and we have seen this 2, and we substitute x equal to 0 in line, this is 0, therefore 2 is greater than 0. That's why in between -1 to 2 this parabola is above. That's why we have drawn the diagram like this. Now our required thing is what? Our required area is in between -1 to 2, the area bounded by this line and the parabola. This is the required area, the shaded area. So here we have seen this 2 is greater than 0. That's why this y1 is what? This parabola, this, and this y2 is line. So here see this y1 is what? y1 is 2 minus x square. So this y2 is -x. You can write like this. So now the required area is equal to, just you substitute y1 and y2 in this one. So required area is, therefore required area is equal to integration of -1 to sorry, this is, I think this is +2 kada. Yes, this is +2. Yes, integration of -1 to 2 y1 minus y2. So y1 is what? 2 minus x square minus y2 is -x whole dx. So this is equals to integration of -1 to 2, this 2 minus x square plus x dx. So this is equals to, this is integration of 2 dx, 2x minus x cube by 3 plus x square by 2. Limits are from -1 to 2. So if you substitute upper limit, therefore 4 minus 8 by 3 plus 4 by 2, which is 2, minus of -2 here, plus 1 by 3 plus 1 by 2. So which is equals to 6 minus 8 by 3 is the first bracket, minus second bracket is, so here what we do here, oh, if you open the bracket, otherwise Okay, if you open the bracket, plus 2 minus 1 by 3 minus 1 by 2. So this is equals to 8 minus 8 by 3 minus 1 by 3 minus 1 by 2. So which is equal to 8. So if you make the denominator same, therefore what we do is, this is 16 by 6. If you multiply and divide by 2, here 2 by 6 minus 3 by 6. So which is equals to 8 minus 16 to 18, 19 to 21. 21 by 6. Yes, now 3 2s are 3 7 times. That is 16 minus 7 by 2. That is 16 minus 7 is nothing but 9. Yes or no? 9 by 2. Yes, 9 by 2 square units. This is the required area. So required area is this 9 by 2 square units. Next question is, calculate the area enclosed by the parabola AY is equals to 3 times a square minus x square and the x-axis. So this is the question. Solution. So the given curve is, the parabola is AY is equals to 3 times a square minus x square. So if you observe the coefficient of x square is negative, therefore the parabola is open downward. That is the first observation. Now what we do is, so here first one is, here sorry, parabola coefficient of x square is negative, the parabola is open downward. Here coefficient of x square is negative, parabola is open downward. Now where this parabola meets the x-axis? So the parabola meets the x-axis for meeting points on x-axis, you put y equal to 0. If you substitute y equal to 0, then what you get, a square minus x square equal to 0. That implies x square equal to a square, x equal to plus or minus a. Therefore this parabola meets the x-axis at minus a and plus a and open downward. Sorry, is open downward because coefficient of x square is negative, and it meets the parabola, it meets the x-axis at x equal to plus or minus, because on x-axis y equal to 0. If you substitute y equal to 0 in this one, you will get x square minus a square minus x square equal to 0, x equal to plus or minus. So now the question is, the area enclosed by this parabola and x-axis. So now we will draw the diagram. So for diagram, is y-axis and x-axis. So this one is x-axis, and if you draw this parabola, this, and one more thing, where this parabola meets the y-axis, on y-axis x equal to 0. If you substitute x equal to 0, then what you get, ay is equal to 3a square. So a is not equal to 0, therefore you can cancel, y is equal to 3a. So where this parabola meets the y-axis, at 3a. Now you can draw the diagram. So this is the diagram. So this is the graph. So now where it intersects the x-axis at minus a and a, therefore so this is minus a and this one is a. So here the limits are these vertical lines. So x equal to minus a and x equal to a. These two vertical lines are lower and upper limits. So this is x equal to minus a is lower limit, x equal to a is upper limit. Now the required area is equal to the shaded region. The area bounded by the, and this is y-axis. So this is y-axis. So the area bounded by the x-axis and the curve. So this shaded region is the question. So now the required area is, this is our curve, that is y is equals to, what is the curve? Y is equals to 3 times a square minus x square over a. So now the required area is, so required area is equal to integration of minus a to a, so y dx. So this is equals to integration of minus a to a. What is y here? Y is equals to 3 times a square minus x square over a dx. So this is equals to, now if you observe this integrand, it's an even function again. If it is an even function, therefore minus a to a f of x equal 2 times 0 to a. 3 a square minus x square by a dx. So because if the function is even function, therefore this total area is equal to, if the function is even, therefore symmetrical about, the function will be symmetrical about y-axis. If the symmetrical about y-axis, minus a to a, this f of x equal to 2 times 0 to a f of x dx. అంటే ఈ మొత్తం ఏరియా మైనస్ ఏ టు ఏ ఎఫ్ ఆఫ్ ఎక్స్ డిఎక్స్ క్యాలిక్యులేట్ చేసిన 0 to a 2 times చేసిన సేమ్ వస్తుంది, బికాజ్ ఈవెన్ ఫంక్షన్ is symmetrical about y-axis ఉంటుంది కాబట్టి. That's why we have written minus a to a is equal to 2 times 0 to a. Now this is equal to 6 into integration of 0 to a square minus x square over a dx. So now this is equals to, so this is equal to 6 into, if you integrate it, if you separate it, otherwise integration of 0 to a, this is a minus x square by a dx, so which is equals to 6 times, so integration of a constant, a into integration of dx is x, limits are from 0 to a, minus 1 by a into integration of x square is x cube by 3, limits are from 0 to a. So this is equals to 6 times, this is a into a minus 1 by a into, this is a cube by 3, that's it. For lower limit it will be 0, therefore 6 into a square minus, this is a square by 3. So this is equals to 6 into 2a square by 3. So that is 2 times, therefore 4a square. Therefore 4a square square units. So the required area is 4a square square units. This is the shaded area.